See, I just need to tell you something. Linux sessions are boring. Okay, I accept that. Okay, and I'm always giving you the flexibility. Don't be in a hurry to practice all the Linux commands that I have covered in the last 2, 3 classes. Take your own time. Okay, this is more than what is actually required. So take your own time. Take 1 month time. Finish off the Linux part. Okay, the basic Jenkins is the first tool that I'm going to start in DevOps. Does not require this much Linux knowledge. So how to create files, how to create directories, how do you delete them, how do you move from one folder to another folder. This much basic Linux knowledge if you have, we can actually start off with the course. So what I will do is today also we'll work on some miscellaneous commands of Linux. Tomorrow and day after tomorrow, I'll just try to give introduction to some basic cloud services. Because when I start the sessions on Monday, we will be setting up the entire infrastructure on the cloud only. Any cloud you can use, AWS or Azure, doesn't matter. I'll show you on both the clouds. But it's better that you have some basic understanding of how that cloud architecture works. That we will cover. The actual tools will start from Monday. So what we have been doing since this entire week is only getting ourselves ready by understanding Linux commands and also by understanding some basic cloud fundamentals. Okay, nothing beyond that. Actual course we did not yet start. Okay, so please keep that in mind. As far as the Linux commands are concerned, take your own time. Don't be in a hurry to practice all these commands. See, I think yesterday also some of the students raised this doubt that I am teaching on Azure. Why not on AWS? I'm not teaching Azure or AWS. We are just working on Linux. I'm just taking a Linux machine from the Azure cloud. I can take the same Linux machine from AWS cloud or Google cloud. That's why I showed you all the alternatives. Okay. We are not talking about cloud currently. We are just understanding basic Linux commands for the time being. Okay. Fine. So let me start my server. We were talking about a command yesterday called as the chmod command, right? The purpose of chmod command is to change the permissions, files permissions. If you want to change, we generally depend on the chmod command. Now, there is actually one important definition that we generally give whenever we talk about Linux related commands. You know what that is? Linux operating systems treat everything as a file. We say that in Linux, everything is a file. What does that mean? You know how to create files, touch command or cat command we have seen. Similarly, there's one more command called VIM, which we will see. These are various ways of creating files. How do you create directories? mkdir. Though you are calling that as a directory is nothing but a folder. Internally, your Linux operating system treats that as a file only. Now, not just files and directories, the softwares that you are installing on your Linux machine, the hardware gadgets that are connected to your Linux machine, that is also treated as a file. And a keyboard is a file, mouse is a file, your CPU is a file, your RAM is a file. Everything is treated by Linux as a file. Internally, that's how it perceives everything. Now, what is the advantage of treating everything as a file? The same chmod command that we have learned yesterday, through which you are modifying the permissions of regular files. Via that, I can also change the permissions of a pen drive or a mouse or a storage, hard disk or RAM or anything I can do. We talked about read permission, write permission, and execute permission. Permissions are given for 3 people, user, group, and others. The same chmod command through which you are working on files. Let's say tomorrow I insert a mouse. That mouse will be shown as a file. I can use the chmod command and I can change the permission so that I can tell that, okay, only so and so person should be able to use this mouse. You're understanding? That is the beauty, because everything is treated as a file. With the simple chmod command, how you are able to control access on a file, you can also control access on your hardware also. Okay, that's a slightly advanced thing, but we'll understand that as we go with the sessions. Fine. So when we stopped the class yesterday, I was talking about something called as the UMask value. Okay. So on a Linux machine, please keep in mind always in any Linux, irrespective of the Linux distribution, in any Linux machine, there are two types of users. One user is called as the root user and all other users are called as ordinary users. Root user ante vaadu owner anamata. He has complete control on your Linux machine. That fellow can do anything. He can even crash the server. Ordinary users are people like you and me who are working in a organization. We will have limited permissions. Okay. Once you log in into a machine, I already showed you there is a command called as who am I, which will tell you what is the username with which you have connected to the server. In my case, the username is shown as Azure user. When you people are doing it, you might find something else. In your organization, probably your name will be there. When you say who am I, your name will come up. Okay. Root user will have unlimited permissions. Here, to go into the root account, the command that we are using is su. Su stands for switch user. Sudo ante temporarily higher permissions. Okay, that's we'll discuss that. Su stands for switch user. You are going into which user? Root user. After doing this, if I give the command who am I, you notice that the username is root. See, here, who is the owner of this cloud account? AWS or Azure? I am the owner of the account, which means I have complete control on everything. That is the reason I am able to go into the root account. But in the company where you are working, let's say you are using AWS. Are you the owner of the AWS account? No. మీరు ఏ కంపెనీలో అయితే పనిచేస్తున్నారో your company will be the owner of the AWS account. They will be paying money for the AWS account, which means you are just ordinary employees. As an ordinary employee, you will not have permissions to go into the root account. Here I am able to go because I am the owner of the server. No one can stop me. But in your real time, if you try to execute this command, it will not work. You cannot go into the root account because root account means unlimited permissions. You can literally do anything. It's too much, way beyond what we can currently imagine. That fellow can give any kind of permissions to the team members. He can delete team members, anything he can do. So root access is not given for everyone. Hardly one or two people will have root access on the server. Other people will have only ordinary access. Now, what I was trying to tell you yesterday is when the root user creates a file, see, I am creating a file. After creating the file, look at the file 1. What are the permissions on the file 1? 644. Oppukuntara? Read and write is 6. Read 4. Read 4. When an ordinary user is creating the same file, it is coming with 664. Root user is creating, it is coming as 644. Similarly, if the root user creates a directory, look at the permissions 755. This is what I told you yesterday. There are two types of users that we have on a Linux machine, and depending on which user is creating the file, the permissions change. It's not the same for both the users. See? When you are logged in as a root user, and the second one is when you are logged in as a ordinary user. As a root user, if you are creating a file, the file comes with a permission called as 644. And if you are creating a directory comes with a permission called as 755. If ordinary user is doing the same thing, the file comes with a permission 664. Directory comes with a permission 775. This part you will understand only if you remember what I told you yesterday. Remember, read is represented using 4, write is 2, execute is 1. ఈ 3 నెంబర్లు గుర్తుంటేనే మీకు అర్థమవుతుంది. Okay, so what is the meaning of 644? Read and write for the owner. Group is having only read and others are having only read permissions. Whereas if an ordinary user is creating, owner is having 6. 6 means read and write. Group is also having 6, read and write. Others are having only, okay. When I say others, You know, one of the student, once the class was over, he was getting confused. Others అంటే ఏం లేదు. పతి పత్ని or ఓ అంటారు కదా అది. Okay. See, if you are creating a file, you are the owner of the file. You will have one kind of permissions. Let us say you are working for a DevOps team. I'm sharing that file with the DevOps team. DevOps team will have group permissions. I am the owner. I have all the permissions on the file. I mean, I have one kind of permissions. The group, my DevOps team is considered as group. They will have one kind of permissions. Anyone who does not fall under the category of owner and group is called as others. They will have another kind of permissions. This is how you categorize the permissions on a Linux machine. And the default value of these permissions, as I said, is controlled with the help of a value which is known as umask value. If time permits, today you go to ChatGPT or whatever and just try to find out what is umask in Linux. Okay, just for additional information. Okay, it's not compulsory that you should know all these things, but it's good if you know it. Fine. Now let's move into the next part. Since we understood how to change the permissions and all those things, now I will talk about some commands which are related to process management. Process management in the sense, see, on your Windows machine, you people can see how much memory you have, how much CPU you have, system information is available. Kada? See, for example, if I go into something called as system information, it is showing me the hardware resources that I have on my computer. What is the operating system that I am using? What is the kind of processor that I am using? What is the architecture of the process? You can click on hardware resources. Here also it will give you all the information. For example, memory information I want to see. Everything comes here, right? When it comes to a Linux machine, if you want to see the current hardware related information, of course, you have to depend on commands. The first command that we are going to see is a command called free command, free, F-R-E-E. Free command is used for capturing the memory information. How much memory is available? Out of that, how much is consumed? Memory and RAM. Okay, how much RAM is available? How much is consumed? How much is freely available? All that information. So see, I'm giving a command called free. It seems this much memory is available. Out of this much is used. How much is free? Now, generally, the free command shows the memory information in kilobytes. That is the default. I don't want to see in kilobytes. I want to see in megabytes. Then I have to use an option free-m. When you give free-m, the memory information will be displayed in megabytes. See this? It seems approximately we have 7,892 MB of memory. Out of this, how much is used? 753 MB is used and 6,900 MB is still available. I want to see this information in gigabytes. Tell me what will be the command? -G. Okay. And now you see, it shows that as of now, 7 GB of memory is available, 0 GB is used, almost 6 GB is free and all that. So your system memory RAM information can be seen with the help of a command called as free command. Okay. Similarly, on your Windows machine, you have partitions, C drive, D drive, like this, we have partitions, right? Windows is user friendly, so partition names are also more easy to understand. Linux also has partitions, but those partition names will not be that much like C drive, D drive, అలా ఉండవు అంత ముద్దు పేర్లు ఉండవు చూస్తే అది ఒక కమాండ్ లాగా చెత్తగా ఉంటాయి but they do have partitions. That partition structure can be seen with the help of a command called df-h. df-h will show you the list of partitions or devices which are mounted on your computer. Okay, see this. I'll try to explain it. Let's look at my personal computer directly. Let me open my personal computer, and on the computer, if I go to this PC, how many partitions are there? Only C drive. But if I insert a pen drive now, it will show as a D prompt. As of now, there is only C drive. But if I insert an external hard drive into my computer, it will immediately show as D drive or something like that. Similarly, on your Linux machine, the df-h shows you the existing partitions. Unlike C, D, such fancy names are not given. The first partition name is hyphen gadu // okay. The second partition name is /dev/shm. Next partition name is /run. Like that, different partitions are there. You can see the size of the partition, how much is used in that partition, how much is available, the percentage of how much is used, all that information is shown here. Okay. See, on a Linux machine, that word root that we are using generally creates confusion. I just need to clarify that. There are three places where you use the word root. All these three roots are different. Root to root to root. We give that word root, but actually they are different. What is that? I'll tell you. Your Linux file system, always, any flavor of Linux, it starts with /. This / is known as the root directory. Any Linux starts with / only. Within the / only, you will have your subdirectories, files, etc. Within this /, there is another folder, and the name of that folder is root. That is different. Okay, it's a subfolder present in the /. Of course, you have other directories also, like there is a directory called as home directory. There is a directory called etc directory. There's a folder called as bin folder. There is something called as var folder. Like this, n number of folders are there. Okay. Now, a few minutes back, I told you that on a Linux machine, there are two types of users, root user and ordinary user. Root user ante only one person will be there. Ordinary users, multiple people will be there. Okay. Now let's say this fellow is your root user. Okay. What is that fellow's name? Root. Now, other employees are there working in my company. One person's name is Sai. Another person's name is Hari. All these are employees in my company. When these ordinary employees log into the Linux server, the default folder on which their home directory will be present is a folder called as home folder. Whereas when the root user logs into the Linux machine, the default folder where he will be working is a folder called as root folder. Understanding? See, listen carefully. Here, the word root is the name of a person. That is the admin. He is the one who is having complete control on your Linux file system. When that fellow is logging into the Linux server, the default folder, default workspace is a folder called as root. This root is present in /, which is also called as root directory. All of them are different. Okay. Same, see, in Windows also, I can create a folder with the same name. See what I'll do? I'll just go to my computer, maybe to my desktop or something, and let's pick up some folder. See, I'm in a folder called, look at this one, courses. Courses parent entity. If I want, I can create one more folder with the same name. So now see, if I go into this folder, you are in this folder, courses. The parent of that courses is courses. The parent of this one also is courses. Similar to that, your Linux file system is starting with /. That is called as a root directory. In that root directory, there is another folder whose name is also root. What is this directory? This is the home directory of your system admin. System admin is nothing but the root user. When the root user logs in, the default folder where he will work is root folder. Whereas ordinary employees like you and me, when we log in, the default directory will be a folder called as /home. Okay. So Linux file system always starts with this /, and that / we call it as the root directory. Or if you're getting confused, simply call this as /. But that is the parent of your entire Linux architecture, entire Linux file system. Okay. Fine. We talked about free command and df-h command. Free command is showing you the memory RAM information. df-h command is showing you the partition structure, how many partitions are there, etc. There is another command called as du. Du stands for disk usage. For example, you created a file or you created a folder. In the folder, you created multiple files. that folder will be consuming some amount of storage. How much storage it is consuming, I want to see. Du command will help you to do that. See, if I give du-h, and for example, I will give a folder called as var folder. This is an inbuilt folder present on my Linux machine. Wow, very big folder. So many files are there, so it's taking so much time. Yeah, the complete var folder is consuming how much storage? 5.2 GB. Within that var, there is a subfolder called lib that is consuming how much? 4.9 GB. Within that, there is another folder called var lib git that is consuming how much? 4 KB. No, not just var folder. You can give any folder that you want. For example, I want to see etc folder. See, the complete etc folder as such is consuming 7.3 MB of storage. Within that etc, there is a folder called as cron.d that is consuming how much? 16 KB. Disk usage, how much storage is consumed by a particular file or a folder can be seen with the du command. Okay.
Last 10 planes
అది నేను ఒక కాన్సెప్ట్ ఉంది రీడైరెక్షన్ అండ్ పైపింగ్ అనేది చెప్పిన తర్వాత చెప్తే అర్థమవుతుంది చెయ్యొచ్చు ఓకే ఇఫ్ పాసిబుల్ టుమారో విల్ డిస్కస్ దాట్ ఈరోజు టైం సరిపోదు దెర్ ఈస్ అ కాన్సెప్ట్ కాల్డ్ యాజ్ రీడైరెక్షన్ అండ్ piping. Just remind me, tomorrow we'll start our session with this. Once you understand redirection and piping, out of that output, I can just tell, okay, last 5 lines I want, all those things I can do. But wait until I finish redirection and piping. Human readable format. Okay. In this scenario, it is human readable format. df-h lo kuda human readable format. ls-h lo kuda human readable. Anni chotla h ante human readable అని కాదు. ఇక్కడ కలిసి వచ్చింది మనకి. Okay. Let's go to the next one. Please see this. Any computer has certain applications running. Okay. Whether you talk about your personal Windows computer or the Linux computer will have some applications running. Now, these applications are categorized into 2 types. One is applications that I am opening, and there are some applications that the OS is also launching automatically. When you start your Windows computer, what happens? The Windows also would be running some processes in the background. System processes, we call them as. Some processes I will open. Let's say I am opening MS Office. MS Office is something that I intentionally opened. But the very fact that your Windows operating system is running means some applications are running in the background. Similarly, on Linux also, you have 2 types of processes. One is a user-defined process. As a Linux admin, I am creating some processes. The next one is called as system-defined processes. The OS is spinning some processes. PS is the command which will show you the processes which are running. Okay. Currently, we are in the root account. I will log out of the root account. See, PS command shows you the list of processes which are running. It shows when I executed the PS command, it seems there are 2 processes which are running. What are those processes? One is bash and other one is called the PS command itself. What is bash? See, I think I talked about this earlier. Linux has various shells. Shell is nothing but the command prompt where you give the Linux commands. The architecture of your Linux goes like this. You have your hardware. On top of the hardware, you have, the innermost layer of your Linux operating system is called as the kernel. And on top of the kernel, the outer layer is called as the shell. Kernel and shell, both of them combined together is what we are calling as the OS, the Linux operating system. N number of shells are available in Linux, out of which the most popular shell is called as the bash shell. Okay, so you can understand it as a command prompt where you give your Linux commands. Whatever commands you are giving are taken by the shell and they are performed on the kernel. So in my case, if you look at my Linux server, PS shows that currently you are running a process called PS process, and there is also a shell called as bash shell. These are the processes that I have initialized and which are running at this point of time. The system also initialized some processes which are running in the background. That also I want to see. The command is ps-ef. ps-ef will show you the list of processes which are running in the background as well. Not only user-defined processes, OS-defined processes are also available. So, shouldn't so many processes are there. The very fact that the OS is running is possible only because so many processes are running in the background. All that information it is showing. Fine. One more thing. On Windows, all of us are aware of Task Manager. What is Task Manager? It will show you the processes. You can kill a process, right? How do you go? Control Alt Del and I click on Task Manager. And see here it shows you the live monitoring. What are the applications? How much CPU they are consuming? How much memory they are consuming? Continuously it keeps on changing. Dynamic data. Similar dynamic data, if you want to see on a Linux machine, there is a command called as top command. Top will show you the dynamic monitoring of the processes. Just look at my screen. Of course, it shows you the users who initialize the process, the priority. There is something called nice value. I'll talk about that. But mainly see how much CPU is utilized for that process, how much memory that process is using. And you will notice that every 5 to 10 seconds, this data keeps on changing. Because when the application is running, it fluctuates. It takes more memory or less memory. So accordingly, this keeps on changing. Task Manager on Windows was very glamorous. Windows is graphical user interface. You cannot expect that kind of glamour in Linux. But slightly glamorous output I can show you with a command called as htop. Htop also will give you the same information that you have seen in top command, but slightly more colorful. Okay, the same information comes up. If you are fed up with that black and white screen, this is slightly more colorful. Nothing beyond that. It shows you the live monitoring of the processes. It's just an alternative for the regular top command. Okay. Next. See, whenever you notice that a particular application is becoming unresponsive, you go to your task manager and you end the task. You forcibly delete that. Similarly, on a Linux machine also, you can kill a process. To kill a process, Linux has provided a command called as kill command. Kill is a Linux command for forcibly stopping any process. Okay. This kill command is generally given with two signals. One is called as kill-15 signal and the next one is called as kill-9. 15 and 9 are two different signals through which you can forcibly stop a process. What is the difference? Let's understand. Kill-15 is called kill cleanly. Ante neat ga champestadanta. Kill cleanly. That is the word they are using. Kill cleanly means, I'll try to explain it. Listen carefully. See this. Imagine you are trying, there is a process called as A process. A process created two child processes. The names of those child processes are B and C. Now you are trying to kill the A process with a signal called as 15 signal. 15 signal means kill cleanly. Kill will come to this A, it will try to kill it, but it sees that A has two child processes, B and C. So what kill-15 will do? It will wait for the B and C to finish their work. Once their work is over, then it will kill the A process. That is why we call it as kill cleanly. If any dependent processes are there, your kill-15 signal will wait for the dependencies to finish off their work and then it will kill the parent process. On the other hand, if you try to kill with the help of a signal called -9 signal, this is called as kill forcibly or terminate forcibly. What it will do? It will simply come and terminate that A process. It will not wait for the B and C to finish their job. Then you know what will happen to this B and C? They will become what are called as zombie processes. Zombie ready usera? They'll become zombie processes. Zombie processes in the sense they'll be just going in your machine, but they are headless. They cannot do any activity, but తిరుగుతూ ఉంటాయి, తలకాయ లేకుండా తిరుగుతూ ఉంటాయి కంప్యూటర్లో. ఓకే, సో kill-9 signal is something that we give very rarely. Only when you notice that some process is really creating issue, you have to forcibly delete it, then only we go with kill-9 signal. Generally, we go with kill-15 signal only. I'll practically show you the difference with a simple command so that you can understand. See this? When I give ps command, you notice there are two processes running. One is bash and other one is PS. Bash is the shell. Shell and it is the connection with the Linux server. Okay, so I will say kill -15. What is the bash process ID? 1535. In your case, it could be some other ID. 1535. See, I am trying to kill the bash process with the 15 signal. Nothing happened. Still the bash process is running. So what does that mean? Bash has some child processes. And your kill -15 signal is waiting for the child processes to finish their job. Kill cleanly. It will wait for the dependencies to finish off their task. Then only it will kill. On the other hand, if I try to kill with 9 signal, what is the process ID? 1535. The moment I hit enter, sorry, I'm sorry. Kill -9 I'm supposed to give. I'm really sorry. Kill -9. The moment I do that, do you notice the connection to that server is closed? Because the bash shell is the connection to the Linux server. That connection is closed. You are again back to your Windows machine. Again, I have to connect freshly to the Linux server one more time. See, now again, if you give PS command, a new bash process is created. This bash process ID is 1813. Understanding? Kill -9 signal is used only in scenarios where you notice that a particular process is consuming all the hardware resources and it is not allowing you to do any other activity. Forcibly, we want to terminate that process. Then we go with the kill -9 signal. Forcibly, you are trying to kill it. Generally, in your real time, when you are working in a company, don't think that anytime you can execute kill command and all that. There are certain restrictions. Only in certain activities, we call them as severities. Okay. As part of SRE roles, I'll explain them. For certain severities, they'll tell that you can execute these commands. Then only we'll run the command. Otherwise, indiscriminately, you and I cannot kill a process that might create some dependency issues and all that. Okay. So we execute these commands very carefully. Is the RAM information in our system or servers? Ramakrishna, I mean, if you're talking about the free command, the RAM information is coming from the Linux server, not my personal computer. All these commands are executing on the Linux machine. They're not happening on my personal computer until you give exit. When you give exit, then do you notice you're back to your personal computer? But once you give that command, SSH command, you are connecting to the Linux server. Whatever commands you are giving are happening on the Linux server only. Okay. I'll stop the session for now. Okay. Tomorrow, please remind me, I want to start with a concept of Linux, which is called as redirection and piping. Once this concept is over, then we will move into some cloud fundamental basics and all that. And accordingly, we'll try to move ahead. Okay. So before I close the session, any questions you want to ask, you can please go ahead.
Yeah, I have a question.
Just a second. Yeah, please tell me.
Yeah, so you showed a user redirecting from root user, Azure user to root user, right?
That's
To
true.
again switch back to root user, sorry, Azure user.
Just give exit. Just
Okay,
type exit over there. See,
thank you.
what is happening is, this is my Windows machine. From the Windows machine, I connected to the Linux server. As which user you connected? You connected with a
Azure user.
username called as Azure user. Sitting in the Azure user, if you are giving a statement exit, what is happening? You are coming back to the Windows machine. But what I did from Azure user, I switched into root user. Now sitting in the root user, if you give exit, where you will go? You will go back to the Azure user. One more time, if you give exit, you will come back to your Windows machine. Okay? That's it.
Thank
Process IDs. The top command actually shows you have to search based on the process IDs. See, this is the process ID, and pick up the process ID and you have to search for the dependencies based on the priority and all that. I think probably htop command shows that in a much more better way. Here it's not showing that. Parent process ID అని ఒకటి ఉంటుంది. Just a second. PPID. ఎక్కడుంది? ఇక్కడ లేదు కదా? That's what ఇక్కడ కనిపించడం లేదు. Let me just check for htop command. Here also it's not showing. Maybe there might be some other command where you will have something called as PPID.
Yes.
PPID stands for parent process ID. So you take up one ID and compare that with the other PPIDs. There you will actually find it. Maybe not if htop command, some other command will show that. I'll just check what it is. Here it's not showing. It's only showing you the PID. Generally in the top command along with the PID, we used to get the PPID also. Okay, but I'll check it. Okay. Yeah. So I think that's sufficient for today. We'll wind up the class. Okay. We'll continue tomorrow. Online students, I'll close the meeting.